Again, good morning, dear students. Today we are going to talk about chapter 3. So, talking about differential equation or differentiation. In this chapter, the subject is around how to find the derivative of function. For example, if you have f of x is equal to x squared, as you know, f prime is equal to 2x. In this section 1, the writer of this book is going to tell you about the important things useful of the derivative. First of all, we have a slope of function of the curve. If you have a curve, you have a slope, and how we find the slope by the derivative. So this is the derivative by definition. Here in this year in the university, we don't care about the definition way. Just know that the derivative means that the slope. Okay, and for more information you can read example 1 or example 2. Okay, example 2 or anything else. We don't need to focus on this section really. The section is going to talk about the application of derivative. This subject can be useful for your, for example, your report in case you need it. And how about the derivative is related to the rate of change, and also there's another example talking about how to find the derivative by the definition. You can see it's like the previous one. Okay, so there is nothing to be really here to be discussed, just the rule and nothing else. And how to put the x naught in the derivative, as I mentioned, there is no important for us. And again here are going to talk about in the page 3, talking about the benefit of the derivative. The important things here is the cases in this page number 4. So the 3.1, page number 4 is give you more information. It's very important. He's going to tell you about where the derivative is not exist, where we have a derivative or not. So when does a function not have a derivative? We have a for case, a corner, for example, like f of x is equal to absolute value of x. You know, in this case you have a corner. When I say corner, means that you have a at least 19 degree the angle. So in that case the derivative at the corner does not exist. Why? Because you can find many infinite lines, slope line or tangent. So in that case you see the derivative does not exist. So the case number 1, we have what? We have the corner where one side derivative different, means that the derivative of the right is different from the derivative to the left. That's all. Okay. The second case is cusp. Cusp means that something like that. Okay, for example, y is equal to 1 over x. You know the image of the 1 over x is like that. So you have a cusp, like a hilal, like a cusp. So what's the definition of cusp? Is the approach of one side is going to when you at the 0 you have a cusp. So at the 0 you have no derivative. Why? Because when I'm going to the one side, I'm going to get positive infinite. When the limit is going to the other side, to the left side, the result is going to minus infinite. So this is the definition of the cusp here. I don't need the definition really in the exam. Just be careful when you have a cusp. There is no derivative. You have a corner. There is no derivative. Again, vertical tangent. The vertical tangent, for example, if you have approach to infinity, from both side you get what? You get infinity and minus infinity. Okay, for example, we have a tangent, vertical tangent for the case number 3. F of x is equal 1 over x squared. You can see we have this like a cusp, but something different here. We say recall tangent line. Why? Because you see from the both side approach to the infinite. When I'm going to 0, is going to infinite. When I'm going to the 0 from the left side, also I'm going to get infinite. So that's in the both case we have a infinite. In that case we say we have what? Vertical tangent. How about discontinuity? If the function has a discontinuity, so this we cannot find the derivative at this point, that we have a gap, we have a discontinuity. That's all about the section 1. I'm continuing this video by talking about the section 2. Okay, in section 2 you can see we have some rule here. Section 2, differential rule. I'm going really quickly in this section because you heard this one in your in the grade 12, okay, in the high school. So for example, derivative of the fixed number function, constant function, is equal to 0. For example, if y is equal to 5, y prime or dy over dx is equal to 0, you know. Okay, how about if we have a x to power n, power positive? For example, we have y is equal to x to power 3, then y prime is equal to 3x to power 2. 3 will coming down and we will decrease the exponent. That means that, okay, it's a special case. How about general rule? General rule is the same. We have the same things here. Okay, in the page number 2, 3.2, what we have also, you can see there's a many example how to find these. Okay, there's a many example. They are very easy. Why? Because just try to give it put this one down, the exponent, then let the exponent be -1. All of them, they are the same. You can do it by yourself. Really, they are easy. Please try at home. There is nothing to be worried about. If you are worrying about this one, okay, you can see how to find the derivative. That's all. What happened to here? What happened to here? You know, let me give you more detail in this about this example. Example 1, page 2, F. We have y is equal to square root of x2 plus pi. You know, this one can be changed to like 2 plus pi, like 1 over 2, and you can multiply directly. You get what? 2 multiply 1 over 2 plus pi multiply by 1 over 2, and finally you will get what? 1 plus pi over 2. Now this is a y. How about y prime? We say is equal to what? 1 plus pi over 2. Okay, x, because this all will come down, and we reduce this one by -1, so it remains pi over 2. That's all that you have. Okay, that's all that you need. And he changed to 1 over 2 or something like that. So okay, you can do it. And you know this is equal to what? Just this part. You can say is equal to 1 plus pi over 2 x to power pi under the square, because 1 over 2, you know, means that what? That's all about the a rule number 1. How about rule number 2, or derivative constant multiple? If you have, for example, y is equal to 5x squared, you know the 5 will come out at the derivative, 5 will come out without anything. We are going to talk about 2x, you know. So that's all about the c constant. How about another rule? Here's the example. How about the derivative of sum? If you have, for example, y is equal to x squared plus 2x to power 3, you know the derivative will going down one by one. So this one will be 2x and that one will be 6x squared, right? That's all. Means that if you have a addition or sum, the derivative will distribute over them, and you can see the more example here. Okay, and here. Now for another page number 3. Okay, here's the page. Is going to talk about product and quotients. Product and quotient. Product means that multiplication, quotients means that division. So in that case, you have, for example, y is equal to 5 x squared multiply square root of x. You can do separate them, okay, or you can do something else by this rule. You say we say usually if I have f and g, h is equal to function, the derivative of h will be first multiplied for the second plus second يكم ضرب الشيء دوم زائدا دوم ضرب الشيء يكم the second multiplied by first derivative of the first function. So you have uv, u derivative of v or v prime plus v u prime. That's all. Okay. And how about the example? And forget about the notation. How about the example if you have something like that? Now I have what? I have two function multiplied. So that's why I say first we will change this one to u, and I'm going to let this one to be v. Up to you. You cannot do it. You can directly do it. So I'm going to say first multiplication of the second. So 3x squared plus of the rule the second itself multiplied by 2x. That's all that we need. How about the derivative of the quotients? Derivative of the, what do you say, of the part of the division? We have, for example, h is equal to f over g. H prime is equal to g squared, g multiplied by f prime minus, here's the minus, the f multiplied g prime. Alin jere duja jere zarbida tashay sara naqsan sara zarbida tashay jere. That's the rule that we heard about in the high school. And here's another page about how to find the derivative of the quotient. So I'm going to say this is the square, okay, this itself derivative of the numerator 2t minus of the rule, and numerator multiply 3t2. Why? Because the derivative of the denominator. That's all. Okay, and there is nothing to be worried about. Now I'm going to solve this one for you. We have y is equal to x minus 1 x squared minus 2x over x to power 4. Careful, in the numerator we have two functions, u and v, and also we have what? We have u over v, division. So I say y prime, I am going to say derivative of numerator square, jera, okay, ضرب data شاي سرا do function, derivative of the numerator, we have a two functions, so I'm going to say later minus, okay, I'm leave this one later to, because we need a white place, really white space. Let be here, okay, and sari kertaka numerator x minus 1 x squared minus 2x multiply derivative of the denominator. That aşağı yukarı 4x to power 3. That's all. So how about here? Derivative of numerator. I say first. Look, I'm going to solve this one here. First, multiply the second derivative of the second plus the second multiply the first derivative. That's all. So put this here and you get the result. You can see here what did he do? He solved it by another way. He thought that if you are multiplying, numerator is better, so he did it like that. Or you can do like that. It's okay. But really, this one is not easier than this. There are the another method. So try whatever you want to try. So here's the and he do the, what do you say? You can if you separate the denominator for both of them, for this one and that one, for all of them, you will get something like that. And the derivative of here will be minus minus. Okay, let me do it for you in this way. Y, we multiply x minus 1 by x square minus 2x. So multiply, you get what? X to power 3 minus 2x square minus x square plus 2x. Now I'm going to add x minus 3x square plus 2x as he had. Okay, now is equal to what? x3 minus 3x square plus 2x over x to power 4. Okay, now I'm going to separate the denominator because we have one denominator. Careful, if you have plus 1, it's not easy to do it. For example, plus anything else or minus anything else. So that I'm going to divide this one. I'll get what? X minus 1. How about this one? 3x minus 2. How about that one? 2x minus 3. Now how about the derivative? Sorry. This one will come down and the x should be minus 1. So minus minus 1 is equal to what? Minus 2. Now this one is going to be down. So plus 6 and x minus 3. And minus 6 and x minus 4. That's all. And you can find the other way to represent your result. That's all that we have. Okay, dear. Easy, just try to do it, or you can use the other method as we solve it. And there's a second in the page number 5. Let's see. There's the page number 5. We're going to talk about second and higher derivative. Means that the second and more derivative. I'm going to give you something. These symbols, they are very important. Look. What's the difference between F2, F4, let me say that, and F4? Careful, this means that F circle F circle F circle F. How about this? This means that 1, 2, 3, 4, 5 derivative, 4 derivative. So when the function and we have a parenthesis, kawana, with the number, means that the derivative, okay? But if there's a function without the parenthesis, we have means that square, okay? F circle F. Or how many times we are going to take the function. So first derivative is prime. We recall as y prime, okay? Y prime or y double prime or d square over y x square or triple or super n, okay, y super n, we recall like that. Or we sometimes the derivative can represent by the d, especially in for those students that they have a partial derivative. They are going to get calculus 3 or another lectures partial derivative. So we have what? the symbol of prime, or sometimes we have a T2 means that y double prime, or we have fn super 5 means that, okay, or 6, anything that's the all about the derivatives. Now for example, if you have y is equal to x to power 6, okay, and I'm going to say find this number. So you know, first of all, we find prime, which is equal to 6x to power 5. The second will be to power 4. The second, the third will be what? X to power 3. That's all that you needed to find the what? Y super 3. That's all. And there's an example. For example, another example, example 8 in page 5, example 8 in page 5, section 2, 3.2 is going to say what? Find y is equal to x to power 3 minus 3x squared plus 2, find y to 4. Okay, now y prime is equal to 3x minus 6x, and you know the constant will be 0. Double prime is equal to 6x minus 6, and the triple is equal to 6, and the fourth is equal to what? 0. That's all about the chapter 3, section 1 and 2. In the next video we are going to find 3.3. Have a nice time.